Hello, this is a video for the last problem on vector day 2. On the last slide, you're asked to find the work done from a girl pulling a wagon, right? And so I have this preliminary drawing set up for you already. This is the situation that's going on. If you look along the red line, right, this is the direction of the wagon, and we know that it's being pulled 100 feet, right? And the force that's being done in terms of the pulling is F equals 50, and we know the angle of the handle is 30 degrees, right? And so let me first do this and show you how we get to what the slide said, right? So first of all, since we're using 30 degrees, right, we know it's 30 degrees like this, right? That's 30. But in terms of the vectors, well, let me also do this. We know that at 30 degrees, coordinates are root 3 over 2 and 1/2. Okay, we're going to keep that in mind. Now, we got to think of this blue vector as a resulting vector, meaning where does it come from? It comes from this vector here, which is root 3 over 2, and also up along the y-axis, we have this vector here in green, which we know is 1/2. Okay, now I'm going to go back to the horizontal vector here, the root 3 over 2. Since that's the root 3 over 2 horizontal vector, I'm going to label that as root 3 over 2I, and the green, that's a 1/2 j, right? So meaning the blue hypotenuse here, which is the resulting vector of adding the red and the green, this is root 3 over 2I plus 1/2 j. Okay? So that's how we get that vector there, all right, in terms of the unit circle that we are familiar with, right? I'm going to erase this real quick, right? So right now what we have is this is our unit circle vector, all right? Now the thing is, we already know from the problem, going back to the previous setup, that the force is a vector of 50. So if the force is a vector of 50, and we have this unit circle vector of root 3 over 2I plus 1/2 j, that means I'm going to multiply this whole thing by 50, which is what I have here, right? And so the work being done is force times the distance, which is the force we know is 50 times all of this, root 3 over 2I plus 1/2 j, times the distance of 100. Now the thing is, the distance also is a vector, right? We know, going back to the first picture, the distance is 100 feet horizontally, so this also can be written as 100I, and technically plus 0j. So that's what I'm going to use over here in my equation. 100I plus 0j. So then I'm going to multiply the 50 and into this first vector. So I get 25 root 3I plus 25j times the horizontal vector, meaning the distance that the wagon is going, We know that's 100 feet, but again, I'm going to put it in terms of vectors, 100I plus 0j, right? So the first parentheses is vector 1, the second parentheses is vector 2, and really what we're doing is the dot product here, right? We're doing the dot product. And from the previous lesson, or in this current lesson, right, to find the dot product, we multiply the I components, or the I coefficients together. We multiply the j component, or the j coefficients together, and we add those up. So when we do that, we're going to have 25 root 3 times 100 plus the 25j, 25 times 0, right? And that's why if you look at the notes, it makes sense with the answer that we gave you, because 25 times 0, of course, is 0. And we end up with here 2500 root 3 plus 0 is 2500 root 3. And that's how we get that.